Okay, this takes us to our last section, section 2.5, which is linear inequalities. You may or may not have seen this before, but we're going to basically review what you know about the number line and graphing in linear inequalities on a number line. But then we're also going to introduce something that's probably new to most of you called interval notation. So just starting out with a number line real quick in inequalities. If I am graphing a linear inequality on a number line, then the first thing I need to know is about what kind of symbols we use if we have greater than or less than versus greater than or equal to and less than equal to. So if we just have a less than or a greater than, we are going to use open circles. Versus if we have a less than equal to or greater than equal to, we are going to use closed circles. For example, if I wanted to graph x is greater than or equal to -3 on a number line, the first thing I would do is I would find -3. And notice, since this is a greater than equal to, I'm going to use a closed circle there. And that is greater than. That's greater than -3, which means I'm going to graph every number. I'm going to graph in the direction of the numbers that are bigger than -3, which would be the numbers to the right. Okay. We have another example. Graph the solutions of x is less than -5. Notice here there's no equal to, so I'm not going to use a closed circle this time. I'm going to use an open circle at -5. And now it's less than, this is less than, which means we now shade to the left instead of to the right like before. Okay. So what I would like you to do here is go ahead and pause the video, and while you have the video paused, go ahead and try to write out the number lines solutions to each of these 4 inequalities, and then we'll come back and talk about what interval notation is. So again, go ahead and pause the video and write down what you think the answers are. Okay, welcome back. Hopefully you were able to come up with these answers that I have showing here. Notice that this is less than -2, so that's shading everything to the left, and because it doesn't have an equal to there, it's an open circle. The next one has equal to, so we have a closed circle at 3, and this is greater than, so we shade to the right. The next one may be new to you. This is called a compound inequality. That means there's 2 of them in it, or a double inequality. And in this case, notice that x, the values of x, are sandwiched in between -6 and 5. They're greater than -6 yet less than 5, which means the shading is between those 2 numbers. There's a solid circle at -6 and an open circle at 5. And then lastly, x is less than or equal to -6. That's a closed circle there at 6 and shade to the left. Now, interval notation is just a way of representing what we see on the number line in a more compact form, I like to say. So let's go back up here to my 4 little notes here. The first note is that you always go from left to right on the number line when you're writing out your interval notation, just like we read a book, left to right. Also notice that we use brackets when we have equal to, and we use parentheses when it's just less than, greater than, without the equal to. And then we always use parentheses for infinity or negative infinity. Now the concept of infinity and negative infinity is that, you know, on the number line, we always go out to the right. In fact, Let's come back up here to our big one. 0 is right smack dab in the middle. But out to the right is the positive numbers, so we could think of, if we just continue out forever, that would be positive infinity. And then if we go to the left, we have negative numbers, and if we continue to go that way forever, we approach negative infinity. So, if I look at this first example, this shading, this red shading, is going out to positive infinity or negative infinity. Well, since it's going to the left, it's definitely going out to negative infinity. So we can think of this as like negative infinity out here. And remember, we always go left to right. So what we see here, if I start on the left and go to the right, what I see is negative infinity to negative 2. So I'm going to go ahead and write that. Negative infinity to negative 2. And you always separate those by parentheses. And then we're going to go ahead and, for the negative infinity, remember negative infinity, we always use parentheses. So on that side we're going to have parentheses. And then on the other side, the negative 2 side, it's an open circle, which means that it was, remember, it was less than. So anytime we have less than, that's right here, we use parentheses. So all this interval notation is saying is that your answer is everything from negative infinity to negative 2. Negative infinity to negative 2. Let's do another one. This time the shading doesn't go to negative infinity, it comes out here to positive infinity, and moving left to right it would go from 3 to infinity. So we go 3, comma, infinity. And then the 3, this case we do have an equal to. It's a closed circle, which we use a bracket there. And for infinity, remember, we always use parentheses. Notice these first two examples. Parentheses always on the infinities. Third example, there is no infinity. It's between two numbers. And moving left to right, it goes from negative 6 on the left to 5 on the right. So I'm going to go ahead and write negative 6, comma 5. It's a closed circle on the left, open circle on the right, so it's a bracket, parenthesis. It's an equal to and without an equal to, bracket, parenthesis. We might even make a little note up here. Brackets are when we have closed circles, parentheses are when we have open circles. So on the last one here, this is going out to negative infinity. Moving left to right, it's negative infinity to 6. Negative, oops. It's a terrible looking negative infinity. Negative infinity to 6. Always use parentheses on the infinity, and because that's a closed circle, this is a bracket. So that's interval notation. When solving linear inequalities, it's always the same as when you solve an equation, except for when you multiply and divide by a negative. Whenever you multiply or divide by a negative, you have to, oh, and there's a little typo there, that should be just T0, TRTO. You have to switch the orientation of the inequality symbol. So we have to do that in this first example. If I was going to solve this, just like we've been solving equations, we want to get the x's on one side, numbers on the other. So I'm going to need to move this positive 7 to the other side, which makes it a negative 7. If I move it, change sides, change signs. So this is negative 5x coming down, greater than, bring that greater than down. 32 minus 7, 25. Okay, this x is married to the negative 5 by multiplication. Multiply, marry, divide, divorce. So I have to divide by negative 5, divide by negative 5. That cancels those. But now here we go. Notice we divided. We divide by a negative. Divide by a negative. When that's the case, we have to switch this to a less than. We have to switch it from a greater than to a less than. So that becomes x is now less than -5. Okay, if I draw that on the number line, -5 less than, that's an open circle. And I'm going to shade to the left. So this is approaching negative infinity over here. So when I go to write an interval notation, left to right, that's going to be what? It's going to be negative infinity to -5, parenthesis or bracket with infinity, negative infinity, parenthesis, and because that's an open circle, parenthesis. We're going to do one last example here with a double inequality. And double inequalities are kind of cool because you're still solving an equation the way you normally would, except you're solving two equations or two inequalities simultaneously. So the principles still apply, except that when you do it to one side, when you get x by itself in the middle, we need to isolate x in the middle. When you do that, you also have to do it on the outside in both places. So if I want to move this 8 out, if I want to subtract 8, I have to subtract 8 everywhere, on the left, in the middle, and on the right. So I'll cancel there. -10 plus a -8 is a -18. It's a -18. 3x is in the middle and 6 on the right. We could divide everything by 3. We got to divide by 3 to get x by itself, but if I divide the middle by 3, I have to divide the left and right by 3. So doing that, -18 divided by 3 is -6 is less than x. 6 divided by 3 is 2. If I graph that, I have -6 to 2. Those are both less thans without the equal to, so those are going to be open or closed circles. Open. I'm going to shade in the middle. Interval notation, that looks like -6 on the left to 2 on the right. They're both open circles, so we use parentheses or brackets. Parentheses. So the last part of this section is we get to see how we can apply linear inequalities to some different applications. And the nice thing about inequalities is they allow us to compare expressions in mathematics to quantities. So let's see how we can do that. Let's read through this example. It says a rental car company charges $29 to rent a car, plus 10 cents for each mile driven. Susan has $50 in her budget for a rental car. Set up and solve an inequality for the number of miles M that Susan can drive without exceeding her budget. So it looks like she has a kind of like fixed charge that she has to pay no matter how far she drives. The fixed charge is $29. But then she also has a per mile charge. And how much is that? Per mile charge is 10 cents per mile. And we have a variable. They actually define the variable for us. They let M be the miles driven. And so the reason why we can use inequality here is because they talk about wanting to find how many miles M so that Susan drives that car without exceeding her budget. And what is her budget? How much does she have to spend on this rental car? Well, it says right there she has a $50 budget, so her budget is $50. So if we don't want to exceed her budget, this is where the inequality comes in. Are we going to be less than or equal to 50 or greater than or equal to 50? Which one is it? Well, if you exceeded the budget, then you would be greater than. So we definitely don't want the greater than equal to. The equal to we do want, because she can spend all of her $50, but she can also spend less than it. So now her cost should not exceed 50. Now what are her costs? She has two different charges, the fixed charge and the per mile charge. So she has a $29 fee she has to pay, but in addition to that, we have to add 10 cents per mile. So 10 cents times M, the number of miles driven. Now we can go ahead and solve this. We can take and move this 29 to the other side. It becomes a negative 29. And so on the right hand side, we have 21. We still have 0.10 m over here. And how are we going to solve this? You got it. We just divide both sides by 0.10. And when we do that, we can see that at most, Susan should drive 210 miles. Let's say Susan can afford to drive at most 210 miles in the rental car. So that's one example. Let's look at one more. It says, if Billy's test average is at least 80 but lower than 90, then his final grade will be a B. His scores on the first 5 tests are 62, 67, 96, 75, and 85. What scores on the 6th exam will give him a B for the class? Assume your highest possible score is 100. So notice it says his test average needs to get a B, his test average needs to be basically between 80 and 90. So how are we going to treat this problem? For him to get a B, his score needs to be at least 80, so it needs to be greater than or equal to 80, but lower than 90, so that's less than 90. And we're basically averaging his 6 scores. We know 5 of them. We want to know what he'll get on his 6th exam. So let's call his 6th exam score X. Now we know how to find average. We did this at the beginning of the class. We just take all the scores, add them up, and divide by how many scores there are. And we know there's going to be 6 scores, so we just need to add up the 6 scores. So we take 62, that's the first score. We add that to 67. We add that to 96, plus 75, plus 85, plus the last score, we don't know it, it's an X. So we could simplify a little bit here. We have 80 is less than or equal to, let's add up those scores that we do know. So we have 62 plus 67 plus 96 plus 75 plus 85 equals 385. So we have 385 plus X divided by 6 is less than 90. Now, we just solved one like this a little while ago. We want to get the X by itself in the middle, remember? So the first thing we want to do is what to solve this inequality? What are we going to look to do? Well, we got to get rid of this 6, so the way we're going to do that is we're going to multiply by 6 over 1 here, and by 6, or 6 over 1, and by 6. So when we do that, nice thing is those 6's cancel in the middle. So in the middle, we're left with 385 plus x. But on the outside, 6 times 80, that's 480. And on the right side, 9 times 6, that's 540. And so now, when we want to solve for x, we're just going to subtract 385. And remember, with these, we subtracted everywhere. So we subtract 385 there. Subtract 385 there. So when we do that, 480 minus 385, that's 95. Cancel, so this is less than or equal to x, which is less than 540 minus 385. What's that equal to? That's 155. So now he can Billy get a 155% on his exam score? Well, no, because it says the highest possible score is 100. So Billy needs a score of 95 or higher, but the highest he can go is really 100, right? Billy needs a score of 95 or 100 to earn a B in the class. And that's it. This is how we solve different types of applications in using linear inequalities. Don't forget to work on your self-check, and we'll see you in class. Thank you.